Hey guys, in this video I'll talk about how to approximate the area under curves using Riemann sums. Let's say we're given this function, f of x, and we want to find the area under it from -3 to 3. This looks like this area. Clearly this is a curve, and we would need to use calculus in order to find this. But we can approximate this area using Riemann sums and dividing this area into rectangles. Now, left Riemann sums are when the left-hand side of the rectangle actually aligns with the graph. So it would look something like this. If we draw these rectangles, you can see that the top left corner of the rectangle is where the point actually matches the graph, and that's the height we use for each rectangle. So let's say we're given this table. We could find the area by multiplying the bases by the heights. And in this case, the heights are all the left sides. So we would add all these heights, all these f of x's, except for the last one, which would be this point right here. Because the height of the last triangle, the height of the last rectangle, is f of 2. And once we do this, we see a equals 15. Now it's clear that this isn't a perfect representation because there's some parts where the rectangle is under the curve and some parts where the rectangle is over the curve. But this is the method of left Riemann sums, which is a way of approximating this area. Now let's take a look at right Riemann sums. As you may guess, this is where the top right-hand corner of the rectangles align with the graph. So all the heights are the heights of the right side of the rectangles. We'll look at the table again and figure out the area using right Riemann sums. Once again, we multiply the lengths of the bases, which is all just 1, by the heights. Now we ignore the first value, f of -3, because the height of the first rectangle is f of -2. And we sum all of these heights from f of -2 to 3, and we get a equals 17. So once again, this is not a perfect representation because there's some parts where the graph goes over, or the rectangles go over, and some parts where the rectangles are an underestimate. So often you get different results from right and left Riemann sums, and these two are just different ways of approximating these functions. In the next video, we'll talk about midpoint and trapezoidal Riemann sums, which are even more ways to approximate this area.